Good morning, students. Myself, Assistant Professor Jitan Gurjar. Today, we'll see how to derive mean and standard deviation of exponential distribution. So, in today's lecture, we see how mean and variance is derived. So, before that, we'll just go through very simple discussion on exponential distribution. The exponential distribution arises in connections with Poisson's process. A Poisson's process is one exhibiting a random arrival pattern in the following sense. So already you have come across Poisson's process. In the last lecture we have seen it's a random arrival pattern. And how the random arrival is given? For a small interval delta t, the probability of an arrival duration delta t is taken as alpha delta t, where alpha is equal to mean arrival rate, student. So this is what we are going to know. The probability of more than one arrival duration delta t is negligible. Yes, very important. Then inter-arrival time are independent of each other. This is a kind of stochastic process, one for which events occur in a random fashion. So this is what we come across exponential distribution. Under this assumption, it can be shown that the probability distribution function for the distribution of inter-arrival time is given by S, which is known as exponential distribution. So just remember here, in the Poisson's process you already done, where random arrival pattern in the exhibiting process we have got. And then in exponential, what we come across a small interval time delta t, where the probability we are going to take alpha delta t. Alpha is some mean arrival rate, and more than arrival during delta t is negligible. Remember this. And here, whatever the arrival time we are going to consider in exponential distribution, but here you also remember inter-arrival time. That is whatever the inter-arrival time we are going to consider here, it is independent of each other. So whatever the time taken, or it's all independent. And this is a stochastic process. You have to remember what I mean by statistics. It is nothing but statistics process is nothing but the events occurred in a random fashion. Definitely, just see within short time what properties of exponential distribution, friends. If it can be shown that the number of arrival during an interval is Poisson's distributed, yes, then the inter-arrival time are exponentially distributed. Definitely, the mean arrival rate is given by, actually it is alpha, as we have already seen in the Poisson's distribution. But when you take the inter-arrival time, friend, it is reverse. So we have to take this as 1 divided by alpha. So Poisson's distribution is a discrete distribution. So very important. You can see it is a discrete distribution, where discrete distribution is nothing but the distribution which we can count. Yes, it can be counted very easily, and this distribution will give you the distribution step by step, like this 1 0 1 2. So definite interval of time we get the discrete distribution. So even Poisson's distribution is a discrete distribution. Even this Poisson distribution is closely related to the binomial distribution, students, and will be considered. Already we have considered this binomial distribution. Okay. It can be shown for the exponential distribution that the mean is equal to the standard deviation. Yes, definitely. We are going to derive this. Very important, student. This is what we are going to derived, that we see the derivation here. It can be shown that for the exponential distribution, mean and standard deviation are equal, which is equal to 1 upon alpha. This is our today's lecture. Very, very important. This derivation we are going to do. Mean and standard deviation we see they are equal, and it is equal to 1 upon alpha student. Then very simple, we have exponential distribution is the only continuous distribution that is memoryless. I have already you have come across this, and this is what were simple applications. Exponential distribution is a continuous probability distribution used to model the time we need to wait before a given event occurs. And exponential distribution is a tool used in probability theory statistics, so definitely is very important in the statistics students. It is used to test if the statement regarding a population parameter is correct. Yes. So if you just see in the crime cases, whatever the statement is given, is it correct or no, we are going to check using exponential distribution. Also useful in hypothesis testing. Yes, definitely. We come across hypothesis testing in this thing, that if any statement is given, we just check is that correct or wrong, and then we test the hypothesis of that statement, and we conclude the statement is correct, wrong, it is true, hypothesis tested, or false hypothesis tested. We are going to understand, and then we come across the graphical appearance of the exponential distribution. This is what we have. Yes, it is exactly reverse. I can see the R, that is the R sample space increases. What happens? This goes on decreases. It is exactly reverse. That is f of x function decreases. This is a simple points I have made out. You have to remember. So we'll start with this. Our derivation. Very, very simple, students. So let us start. Okay. Yes. So we'll see first mean and variance. We'll start with mean and our standard deviation, friends. Okay, this is what we want to derive today's lecture. So within 5 to 10 minutes it will get over. Very simple derivation we have here, friends. So remembering the above formulas, 1 to 4 points you have to remember. Probability density function is f of x is equal to alpha e raised to minus alpha x for x is greater than 0, otherwise it is 0. Mean is equal to standard deviation, which is mu is equal to sigma is equal to 1 divided by alpha. Also, please remember variance is equal to 1 upon alpha square. It is a continuous probability distribution in the interval 0 and 1. So you have to remember this fourth point, very, very important in the derivation. So we'll start now. You see, already you have come across mean is denoted by mu, which is equal to this continuous probability distribution. Therefore, I'm going to take this as a function from minus infinity to infinity x into f of x dx is learned. So this is what you have to take for continuous probability distribution. Now you can see what is the function f of x. So remaining terms I'll write as it is, and then I will simplify what is f of x. So what remains same here is integration minus infinity to infinity. X remains as it is, friends. And here we have f of x. F of x is nothing but, yes, it is alpha e raised to minus alpha x, and this dx remains as it is, friends. Okay. So this is what from the above we have taken this formula. Then we see how we are going to simplify this, friends. The integration, that is integration u into v, I think by using, so let's see, by using, very simple, by using Bernoulli's rule. So it is Bernoulli's Bernoulli's rule. We can see we can solve this example very easily. Now we will start now. What is Bernoulli's rule says? Keep this mu as it is. I can see here alpha is constant student. So I will keep alpha outside. So I will take alpha outside. Fine. And then yes, it is integration of this is I'm going to take this as u and I'm going to take this as v. So u is equal to I will take this as x and v is nothing but e raised to minus alpha x student. So I will take this now and start simplifying. First integration u into v of dx is equal to first I will take the keep x as it is integration of e raised to minus alpha x. I think you remember that integration of e raised to ax dx is equal to e raised to ax divided by a. So here a we have taken this as minus alpha. Then you have to just simplify this now. So we get here e raised to minus alpha x divided by minus alpha. So this is first part minus and then keep this again integration of integration this part e raised to minus alpha x divided by minus alpha. So if we just integrate this once again, we are going to get this as minus alpha x divided by minus alpha into minus alpha students. Okay, so here we get this as minus alpha divided by minus keep this integration then Bernoulli's differentiation that is d of x is nothing but 1 differentiation of x. So you come across differentiation of x with respect to x, it is always 1 student. That is what we have simplified. And then remember in the Bernoulli's different this one interval in the exponential, what is the interval? We are initially we are going to start with the 0 definitely, and then it must end to 1, but you have given the upper limit as infinity. Sorry. So you can see here students very simple. So in this it is clearly mentioned that here we'll take 0 and this will go on extending till infinity student. That is what the exponential, but they have told here it will end to 1, but upper limit it is not fixed student, therefore it will go to infinity. So you have to remember this that this integration you are going to take this for 0 to infinity x into alpha into e raised to minus alpha x into dx run. So this is interval will now change to 0 to infinity. So this is what we have for exponential run. Please remember this. If it is not mentioned upper limit, then we have to consider this as infinity. If lower limit is not mentioned, definitely we have to take this as 0 because it starts from 0. Then simplify, substitute the values students one by one. X is equal to 0. When x is equal to 0, the first term will become 0. Yes, first term will become 0. And then next term. So in the next term, we can see this is minus and then this is going to become 0, therefore this you will get e raised to 0. So I think I will write this e raised to 0 divided by minus alpha into minus alpha will become plus alpha square. So this is first part we have completed. Then minus. Now we'll substitute infinity. When you take infinity, definitely this e raised to infinity will become 0. So no need to calculate once again. Minus. Now here you can see, students, that e raised to infinity is again 0. So 0 into infinity is again 0 only. Yes, so this is 0. This is clear, students. Then we further simplify this now. This is going to get you, this is equal to alpha remains as it is. Yes, and then e raised to 0 will become 1 divided by alpha square. So this is equal to, students, 1 upon alpha. So therefore mu is equal to 1 upon alpha we get, students. So please remember this. We have calculated for mean. Then we'll go for variance, students. So we see here variance. Is that variance? Yes. We'll go for now variance. VAR is equal to integration, because this is a continuous function, therefore integration minus infinity to infinity x minus mu the whole square f of x dx. This is from continuous probability distribution formula we get this variance. I'll substitute all the values from exponential distribution, that this is going to give you, this is equal to, but always remember the integration on lower limit and upper limit will be, integration will be from 0 to infinity. Keep this x minus mu the whole square as it is. F of x, what is f of x, students? It is alpha e raised to minus alpha, and this is dx, students. So just simplify this. You're going to get this is equal to, yes, alpha is constant, so I'll keep alpha outside. Fine. This you are going to get integration 0 to infinity. Then this is x minus mu square, and this is e raised to minus alpha x. Sorry, this is alpha x you get here. Okay, dx. So again using Bernoulli's, we are going to take this Bernoulli's rule, u into v, integration of u into v, students. I think you must be perfect now. What is the integration of u into v? Keep alpha as it is. So I'm going to take this is equal to alpha as it is. I will integrate first u into v integration. We are going to do, keep x minus mu square as it is, integration of e raised to minus alpha x. Already I told you integration of e raised to minus alpha x is nothing but e raised to minus alpha x divided by minus alpha. This is our integration. Please remember. Okay, then minus differentiation of x minus mu the whole square. So I think you should remember it is 2 into x minus mu, then integration of again e raised to minus alpha x divided by minus alpha will become e raised to minus alpha x divided by, again integrate this once again, so we'll get this as minus alpha into minus alpha. This is our integration. We have integrated this term once again, just please remember, and differentiation of this term. So next again continue this, students. So what we get the value? Yes, this is again minus. Yes, it is minus into minus will become plus, plus minus plus. So again differentiation of this term, differentiate this. It is 2 into dx, differentiation of x is 1, so keep 1 as it is. and differentiation of mu is 0 because it is a constant. Therefore, what remains here, students? It is only 2 remains. Similarly, again integration of this. So continue this integration. So I am going to get here e raised to minus alpha x divided by minus alpha and again minus alpha. So this we are going to do 3 times integration. So if we just again continue like this, here there is no x term, so it is going to get 0. So therefore our interval will remain here from 0 to infinity. Please remember integration remains from 0 to infinity. Now substitute the terms, students, one by one. If you just see, in all the cases, e raised to minus alpha x is there. So when you substitute the upper limit 0, when you substitute upper limit 0, what we get here, student? Sorry, if you substitute x is equal to upper limit, that is infinity, if you substitute x is equal to infinity, if you substitute, this all terms will become zeros. Therefore, only remains with 0. You have to only substitute here 0, but you have to remember that integration of f of x, integration from a to b dx will be what? F of b minus f of a, students. So simplify. So what we get here, students? If you simplify, yes, this is equal to, I will get this as minus, I will keep as it is because this is 0 minus, I will substitute all the terms with 0 integration. Therefore, here we have 0 minus mu square as it is e raised to minus alpha 0, student. So again e raised to 0, e raised to 0 is 1. So here I'm going to get this as minus alpha. Then this is again minus 2, 0 minus mu. This is again e raised to minus alpha 0, means again this is 1. Minus alpha into alpha, I'm going to take this as alpha square. Then this remains plus as it is, 2 remains as it is. E raised to minus alpha x is again 1 divided by minus alpha into minus alpha into minus alpha. I'm going to get this as minus alpha cube, students. I think here it is clear now. There is no doubt. Okay, so we'll continue solving this example. Yes, now you can see what I'm going to get the next values. So if further if you simplify, as you remember one thing, that is mean. So already we have calculated mean. Mu is equal to 1 upon alpha. Remember this, students. Mu is nothing but alpha. Therefore, if we simplify this, mu is nothing but 1 upon alpha. I will simplify this, students. So I'm going to get this as minus, and this is now minus means minus mu the whole square. So minus 1 upon, minus into minus will become plus. It is 1 upon alpha square. So I'm going to take this as alpha square into 1 upon minus alpha as it is. Here minus remains again, minus 2 remains as it is. I will keep this minus 2 as it is. And now substitute here minus 1 upon alpha. I am substituting alphas only, students. So remaining terms you keep this as it is. So here again minus alpha cube, students. Okay, further if you just simplify, so how you, what the answer you will get, we'll just see. Okay, this is equal to, I'll keep this as minus as it is. Now this is 1 divided by minus alpha cube, and here also minus into minus will going to get here plus. It is 2 divided by alpha cube, and here also you can see it is minus 2 divided by alpha cube, students. Yes. and this alpha remains outside here. Please remember here alpha is outside, so just take this, alpha is outside. You have to remember this, alpha is just outside, we have taken it outside. Okay, here also we can see we get here minus alpha outside. Just please remember, as alpha is outside, we missed that alpha, and this is what we get, students. It is, this is equal to minus alpha. Now simplify this, students. We can see this minus and plus 2 divided by alpha cube will get cancelled. What remains, students? Minus 1 upon alpha cube remains, students. So therefore we can further simplify this. Minus into minus is going to get plus 1 alpha will get cancelled, which is going, you are going to get this as 1 divided by sig alpha square, student. Means we have the variance. So what variance, how variance is denoted? It is sigma square is equal to 1 upon alpha square. Therefore standard deviation sigma is equal to square root of variance, which is equal to square root of 1 divided by alpha square. So we are going to get this as again 1 divided by alpha, student. So here we conclude that our derivation mean is equal to 1 upon alpha and standard deviation is equal to 1 divided by alpha, student. So like this, it is very simple to simplify, and simple integration they have given. You have to practice and to conclude this class. Yes, thank you.